Hi students, this is the second unit of mechanics of structure. Okay, this is the name of the topic is analysis of plane trusses. Before into the subject, we should know some basic terms about this subject. Okay, here in this chapter we are going to cover some basic technical terms that only you can solve any kind of problem very easily. This is the definition of truss. What is truss? The pin jointed frame which is used to support the roof is called truss. Okay, just refer this diagram. This is the roof of the truss. Okay, this roof load which is carried by this frame. Okay, this steel structure is called truss. Okay, other is an important technical term. However, no need to concentrate now. Just basic. You should. You are in this chapter. You are going to learn the basic term about this chapter. Okay, so this is the truss. Okay, then this truss member is this truss is consist of the compressive member as well as the tension member. Okay, so what is compression member? The compression member is nothing in this pin jointed frame. If a member pushes the joint to which is connected, the frame in the member will be compressing. The member is called compression member or strut. Okay, simple. I'm going to say the simple definition about the compression member. If the force which is acting towards the joint, okay, that kind of member is called a compression member. And second is the tension member. If a member pull the joint, okay, just keep in your mind, just check that important terms of pull the joint, okay, which is connected, the force in the member will be tensile. This member is called a tension member, or we can also call it a tie member. Okay, both are same, tension member or tie member. Okay, commonly we can classify this frame into two types. One is a determinate frame, another one is a indeterminate frame. Okay, mostly in the university point of view they are asking the repeating a question. Okay, uh, the frame, determinate frame, means a frame which can be completely analyzed using the condition of equilibrium, summation of vertical force equal to 0, summation of horizontal force equal to 0, and summation of moment equal to 0. Okay, so summation of V means is a algebraic sum of the vertical forces. H means summation of H means algebraic sum of the horizontal force. So summation of M means that is algebraic sum of moment of forces. Okay, for example, we can say the roller support, hinge support, or cantilever support of the frames. Okay, so if the frame which is satisfied these three conditions, that kind of trusses is called the determinate frame. Okay, so we can say easily, we can say like what's the difference between the determinate frame and the indeterminate frame. Indeterminate frame is if not satisfy that condition. Okay, if not satisfy that three conditions, summation of vertical force equal to 0, summation of horizontal force equal to 0, as well as summation of moment equal to 0, that kind of trusses, that is called as indeterminate frame. Okay, we can say the example is a fixed at both support. Okay, if the frame which is fixed at the both support, that is called a fixed support frame. Okay, so this kind of frame is called indeterminate frames. Again, we can also classify this frame into two types. One is the perfect frame, second is the imperfect frame. Yes, a perfect frame is nothing. Just read this definition very carefully. So, a perfect frame is that which is compressed of frame just sufficient to keep it in equilibrium when loaded without any changes in its shape. The number of members in a perfect frame may be expressed by the formula n equal to 2j minus 3. Here n is the number of members, j is the number of joint. Okay, simply you can keep in your mind this definition of this perfect frame. If the member which is satisfied this condition, what is the condition? N equal to 2j minus 3. Number of member equal to 2 into number of joints minus 3. If the condition is satisfied, that kind of frame is called a perfect frame. Okay, here from this point you can easily understood about this thing. What is the difference between the perfect and imperfect frame? Imperfect frame is if not satisfied, and imperfect frame is that which does not satisfy the equation. Okay, can you identify the difference between the perfect and imperfect frame? So if not satisfied that condition, n equal to 2j minus 3, that is a imperfect frame. Again, we can classify this imperfect frame into two types. One is a deficient frame, another is a redundant frame. So nothing is very simple. What is a deficient frame? Okay, it's nothing. So n is greater than 2j minus n is less than is 2j minus, that's a deficient and indeterminate redundant frame. Okay, deficient means, it's a definition of a deficient frame is a perfect frame is an imperfect frame. Sorry, a deficient frame is an imperfect frame in which the number of member are less than 2j minus 3. Okay, n is less than 2j minus 3, there is a deficient frame. Redundant frame, a redundant frame is an imperfect frame in which the number of member are more than 2j minus 3. Okay, if it's n is greater than 2j minus 3, that is a redundant frame. Anyhow, this this is a frame which is not satisfy this condition. This kind of frame is called a imperfect frame. Okay, then how can we analyze this frame? Okay, actually in this unit we are going to study about we are going to analyze this frame. Okay, how can we analyze the frame? First of all, determinants of the reaction at the support. We should find the reaction at the support. This is only suitable for the simply supported stresses, not the cantilever support. And determination of forces in members of the frame. Okay, we are going to find the how members how much the amount of force which is carried by that particular members. Okay, we are going to find that things here. Before find these things, we are going to apply some assumptions over here. Based upon this assumption only we can solve any kind of problem. So what are they? Here we assume that all the members are pin jointed. Okay, so there is no hinge, there is no fixed joint or something. Okay, here we assume that all the members are pin jointed. Okay, this is the first assumption. Second assumption is the frame is loaded only at the joint, not other than joint. Okay, very carefully, this is our assumptions. Okay, sometime it will happen or not. Okay, depending upon the situation that may change. However, our assumption is the frame is loaded only at the joints. That is, the frame is a perfect one. Okay, we cannot analyze the imperfect frame. There is a lot of methods over there. Here in this chapter you are going to learn study about the perfect frame only. Okay, fourth one is the self weight of the member is negligible. Here no need to consider the self weight. Okay, and then method of analysis. How many methods are there to analyze this plane stresses? Okay, one is the method of joint, second is the method of section, third is the graphical method. Okay, here in this unit we are going to learn of the first two method of joints as well as the method of section. Okay, then key points. Okay, before solve this, before you are going to work out some problem, you should know some key points about this subject. Okay, there are two types of supports. One is a cantilever support, second one is a simply supported trusses. Okay, how we are going to analyze these trusses? One is a cantilever support truss, second one is a simply supported truss. In the cantilever support, what will you do? How will you analyze that frame? There is two condition when you are going to analyze the cantilever support trusses. Okay, first one is no need to find any support reaction, because in the cantilever support one end is fixed, other end is free. Okay, there is no reaction will happen at the support. Okay, so no need to find any reaction. Second one is directly you can take the joint and work out the forces of the members. Okay, so just you can directly take the joint from this diagram, and after that you can draw the free body diagram at the particular joint. Okay, then you can directly find the forces of every members. Okay, for the simply supported trusses, how can we analyze that trusses? Support reaction also very important. First of all, it's a very important things. Support reaction, you should find this reaction at the support. Then after that you take that any one joint. Okay, take that joint and you draw the free body diagram at that particular joint. Again, then you can continue that procedure. Okay, again you can apply the all assumption over here, and then you can find the forces of each members of these trusses. Clear? Okay. When you solve this kind of problem, that means when you analyze this kind of frame as what it may be, it's a cantilever frame or assembly support, doesn't matter. In this situation, the unit conversion takes a pivotal role to work to analyze the all kind of frames. Okay, if the frame or if the force which is acting towards the downward direction, you should consider is a negative. Okay, if the force which is acting towards the upward direction, you should consider the positive sign. Okay, similarly here, if the force which is acting towards the left direction, you should take negative sign. If the force which is acting towards the rightward direction, you should take the positive sign. Okay, you may ask question like this: why can't I take this as a upward force is a negative, downward force is a positive, or rightward force is a negative, left force is positive? You can do. There is a nothing. Okay, there is a, doesn't matter. The simple things is, if you can take the upward is a positive, you must consider the downward is negative, or else if you consider the downward force is a positive, you must consider the upward force is negative. If you consider the leftward force is positive, you must consider the rightward force is negative. That's a simple difference. Okay, that time only we can solve these equilibrium conditions. Horizontal component as well as the vertical component of inclined member. Okay, that's also very important. It may change depending upon the angle of inclination where is lying. Okay, maybe the angle of inclination from the x-axis or y-axis, depending upon the reference axis, the sign cos may change. For example, look at the picture 1. Here the theta is lying from the x-axis. Okay, this is the theta. So this is the inclined member of the member, that's a f, that's a force. Okay, so how will you give the name of this horizontal component? Very important thing is theta. Okay, and don't forget it. Here f cos theta. If the theta is lying on the x-axis, f cos theta. Here what's the vertical component of this inclined force? This is f sin theta. Okay, here just compare this both diagram. Here come here, theta is over here, it is lying on the y-axis. Here you should take this this is the what is the name of this vertical component? F cos theta. Here that is a f sin theta. This is the very important things, keep in your mind. Okay, the thing is where you are going to take the theta, from which axis, x-axis or y-axis. Okay, depending upon the situation, that sine and cos may change. Okay, here look at here, this is a sine, this is a cos. Okay, because of what? Because of the theta. Okay, thank you for watching this video.